This is the procedure for the CuSO4 stoichiometry lab. We're going to start by reacting solid iron, which is a dark powder, with CuSO4 aqueous, so that's a blue aqueous solution. And we know that one of the products is going to be solid copper. But what we're trying to figure out is what is the other product, which iron sulfate forms in this reaction. So we know from memorizing our polyatomic ions that the charge on sulfate is 2-. But iron, being a transition metal, could form 2+ ions, or it could form 3+ ions. So if it forms 2+ ions, your product will be FeSO4, and that'll be dissolved in water, so that'll be aqueous. Or if the iron is 3+, your product would be Fe2SO4 3 aqueous. And our goal is to figure out which of those two happens. So if you balance the two equations, you'll notice that in the top reaction, the mole ratio of copper to iron is 1:1. In the bottom reaction, once it's balanced, the mole ratio of copper divided by moles of iron is 3:2, right, or 1.5. So basically, it's actually very simple. We get the mass of the solid iron before the reaction, and we get the mass of the solid copper produced after the reaction, change those to moles, and then get a ratio of moles of copper divided by moles of iron and see if it comes out close to 1, in which case we can assume that reaction A actually happened. But if your ratio of moles of copper divided by moles of iron comes out 1.5 or 3:2, then you can say reaction B happens. So it's using stoichiometry to determine the correct balanced equation. So the way we're going to do this is first get the mass of a labeled beaker on the flat top scales to 2 decimal places. We have little labels you can stick on the beaker before you get the mass. Then you want to hit the tare button, T-A-R-E, and that brings the scale down to 0. And then you can start adding solid iron until you get to about 0.30 grams. And when I say 0.30, I don't mean 3, I mean 0.3. So it's a very small amount. And you don't have to get exactly 0.30. You can do 0.29, 0.28, or a little bit above 0.3, 0.32, or 0.33 is fine. Just get somewhere around 0.30 and be sure to write down what you use to the nearest 2 decimal places. So now we know the mass of the iron in the beaker, and to that we're going to add about 15 milliliters of gently boiled CuSO4 solution. So that's that blue solution. What you want to do is get it to the point where it just barely starts to boil, and that should be fine, and then go ahead and pour it into the beaker with the iron, at which point the reaction will start, and you can start swirling the beaker around. Oh yeah, you should also use insulated gloves. It'll be pretty hot when you go to pour it, so that helps you hold the beaker with the hot liquid in it without hurting your hands, obviously. So you pour it in, the reaction starts, swirl it around. It should take a couple of minutes, and then the reaction should be pretty much done. So at that point, you'll know it's done, or you can visually see it if you look at the bottom of the beaker. All right, so look from below, you'll see the copper metal. So it used to be dark black, sort of brownish grayish iron powder, has now become reddish brown copper metal. And that'll be at the bottom of the beaker. So our goal is, can we isolate that and get rid of impurities and dry it so we can find its mass? Problem obviously is that there's this solution above it. So we've got to get rid of that solution, and the way we're going to do that is to pour it off very carefully. That process is called decanting. So we pour off the aqueous solution, but make sure you don't pour it directly into the sink, because if you accidentally tilt the beaker too far, you can pour your copper right into the sink and you have to start the experiment again. So definitely not into the sink. What you want to do is decant into a separate empty beaker decant off that aqueous solution. That way, if you happen to go too far, you can always just pour it back into the original beaker, and you don't have to start again. So you decant off the aqueous solution, but still got a couple of issues. The copper that remains may still have impurities, and it's still going to be wet. So what we want to do first to get rid of the impurities in step 2 is use a distilled water squeeze bottle and squeeze water on the inside of the beaker, right down the sides. Make sure the sides are rinsed and the copper itself is rinsed. So add enough water to cover up the copper. Wherever the level of the copper is, just add enough water to go above that. And swirl it around and decant off that water waste into the same separate beaker you used earlier. So do that twice. And that separate beaker, at that point, you can take the waste, the water waste, and pour that into the sink. So now you've got the copper. It's been rinsed off, so hopefully all the impurities are gone at the bottom of the beaker, but it's still wet. So we want it by itself dry without the weight of the water. So what we're going to do next is repeat step 2, except this time we're going to use a chemical called acetone. So you're going to squeeze acetone down the sides of the beaker, the insides, rinse that off, and rinse off the copper. And then decant off the acetone into that same separate empty beaker you used earlier. Do that twice. And the waste that you decant, the acetone waste, this time you don't want to go into the sink, you want to pour it into the non-halogenated organic waste jar. So very important that acetone and any other organic waste doesn't go down the sink, but into the non-halogenated organic waste. So now the copper's been rinsed with acetone. It's still wet, but when something's wet with acetone, it actually dries very, very quickly compared to water. So if we put the beaker on a hot plate on low heat, should dry in a couple of minutes, as opposed to water, which might take way longer than you have to finish the lab. So at that point, you've got your dry copper in a dry beaker. Let it cool for a few minutes, and then go ahead and bring it over to the flat top scales and get the mass of the labeled beaker in copper at the end. So that's all the measurements you need to do the calculations, and as always during the lab, make sure you write down observations of what the iron looks like before the reaction, anything you see during the reaction, and then what the copper looks like at the bottom of the beaker after the reaction. So in terms of calculations, we are gonna subtract off the mass of the labeled beaker from this third measurement. So that will give us the grams of copper if we subtract off the mass of the beaker. We know at the beginning of the reaction we had the mass of the iron, so if we switch those both to moles, right, so grams of copper to moles and then grams of iron to moles, if we take the ratio, moles of copper divided by moles of iron, we will get a mole ratio that will let us know if reaction A or B happens. So if you get 1 for that ratio, then you can conclude that reaction A happens. But if you get 1.5 as the ratio of moles of copper to moles of iron, since the balanced equation has a 3:2 mole ratio, you can assume that reaction B happens. So you probably won't get exactly 1 or 1.5 because of various sources of error, which of course you'll discuss in your lab report. But you should be pretty close to one or the other, which should allow you to come to a conclusion about which balanced equation actually occurred. So that's everything you need. Good luck, and we'll see you in the lab.